আচ্ছা, ডিফারেন্স বিটুইন টগলিং এন্ড রেসিং রেস অ্যারাউন্ড কন্ডিশন হচ্ছে টগল হচ্ছে কন্ট্রোল স্টেবল এন্ড it has some phases, whereas race around condition doesn't have any controlled or stable phases. So as you can see, there is three technique to control the racing. The first one is t half should be less than the propagation delay. What does it mean? Suppose, or you can say the propagation delay should be larger than the t half. So, for a single t clock, for a single t clock, this portion is called t half. Okay. So, when propagation delay is less than, greater than this t half, it means that to generate a single value, like after generating this one, it will try to generate the second one. So in between, after generating this one, the propagation delay, or it means that to generate the next toggle, it will take some time. That is called the propagation time. So to generate this toggle, the propagation time, if the propagation time becomes higher than this t half, then the racing condition, which means that uh, only this toggle will occur. The second toggle will be needed at least t half amount of time. Means that the second toggle will be take t half, at least t half propagation time. So in this phase, it is clock zero, and after that zero completes here, and only after that it will rise here. So uh, instead of generating multiples of toggling, it will generate only a single toggle only if the t half is less than the propagation delay. So propagation delay কি? Propagation delay হচ্ছে একটা টগল করার পরে নেক্সট টগল জেনারেট করতে ইন বিটুইন যে সময় লাগে সেটাই হচ্ছে প্রোপাগেশন ডিলে। যদি একটা টগল জেনারেট করার পরে সেকেন্ড টগল জেনারেট করার যে টাইম সেটা যদি টি হাফ, যদি এই পুরাটা একটা টি হয়, যদি এই টি হাফের চেয়ে বেশি হয়, তাইলে রেসিং কন্ডিশন হবে না। অর্থাৎ the next toggle will occur only after this, after the only in the second clock, when only the second clock is one. So there. So I hope you understand the first one. And let's see what is age triggering. Age triggering means the rising edge here. As you can see, there is the age is rising. So when suppose it's a clock and it goes from here to there, and after that, in this portion, it will try to rise. So it is very short amount of time where multiples of toggle cannot be generated. That's why edge triggering can control the racing. Whereas if you use the level triggering, where you can see it remains high for a very constant large amount of time. So in between this constant time, the toggling will occur several times, which will create a race around condition. So instead of using level triggering, we can use edge triggering, where there is two type, rising edge and falling edge. You can minimize or you can control the racing, because only when the rising edge will be found, and only that time the toggle will occur. Okay, the third technique is master slave. So this is the very important and very common technique to control the racing system. Let's see how it controls the system. So, like as you can see, this is a JK flip-flop, and also this is a JK flip-flop. So using two JK flip-flop, you can build a master-slave flip-flop, where first one will be master and the second one will be slave. When the master is in operation, the slave will remain deactivated, and when the slave is in operation, the master will remain deactivated. So if we want to activate master, so uh, we will input clock as 1, and it will convert here clock to 0, and it will be used for slave. Okay, so uh, let's see how it actually controls the race around condition. So suppose the last memory element was 0 1. So after toggling, it will need to show 1 0, right? So from 0 0 will be as input here, will go as input here, the 1. So let's see. So we want to put J and K as 1 1, and we want to activate the master. So 1 1 and 1 will here, we found 1 and it will convert as 0, as well as it will create 0 and it will create 1. As you can see, this is a latch structure. So when the latch takes 0 1, it will convert 0 1 to 1 0. Okay, and this one here, the clock is deactivated. It means that the clock is 0. So when in JK flip-flop the clock is 0, it will remain as the previous state. Okay, so so it will remain as it is. Fine. So as you can see, it's 1 and 0, and the slave is not in operation, so it will take the last state as it is. Fine. So it was when the clock is 1, right? In this one. And now when the clock is, let's see, the clock is 0 here. Okay. So in this phase, what will happen in this phase? The clock is here 0. So master will not be in operation and slave will be in operation. So master will remain as it was in the last time. So the last time the value was for master is 1 and 0. Yes. So now, as you can see that the slave is in operation. So slave got 1 from clock. So 1 1 here will be 1, and it will convert 0. And after that, here 1, and from here it will be 0. So it will convert to 1. So as you can see that this is also a latch structure where 0 and 1 is going as an input. So 0 1 will return us 1 and 0. So what we have learned so far, we saw that uh, taking a complete t amount of time where this was, let's see, draw some clock. And here, when the clock is 1, master passes the value, and when the clock is 0, slave passes the value, and the final output value was toggled. From 0 we got 1, and from 1 we got 0. So uh, to a single t amount of time, it was a complete t amount of time where the toggle to occurred. Okay? So this was the operation where master slave uh, toggled the value, and it converts 0 to 1. Okay, and the complements as well. So this is how master slave operation works. I hope you guys got the point, and I think তোমরা বাসায় প্র্যাকটিস করবে তাইলে হচ্ছে আরো ক্লিয়ারলি কনসেপ্টটা বুঝতে পারবো. Fine. Now let's go to the next page. Okay, the operation master and slave removal of racing. So let's see the timing diagram. So we know that when master is in operation, slave is not working. When master is not in operation, slave is working. Also, feedback is wasted. There is no clock for master because when the slave is in operation, master wasn't in work, but removes the racing. So how it removes the racing? Just remember. Uh, let me show the previous slide for once again. As you can see that when master is not in operation, so the output value cannot do anything. Similarly, this one cannot do anything, which was basically racing, created racing, where when master is not in operation, so it will remain the last state as it was. Okay. So let's see the timing diagram. Here, as you can see, during the first clock, rising clock, the master will be activated, and during the clock value is 0, in this time, the master will remain as it was, because we know that when clock is 0, uh, the flip flop only stored the memory state, stored as a memory state. So it remains as it was in the last state. But as you can see, the slave is in operation. So what you can see that this portion is for master and this portion is for slave, and finally you get a toggled value. And again, when master is in operation, like in this time, the master is activated and it will toggle. During this time, master was having 1 and it will toggle the value 0, as well as the slave will also toggle the slave will also, as slave is silent here, slave will also work as a memory state, and after that it will toggle the value as well. As you can see, this is for 1 0 1 0. This is how it's toggling. Well, I hope you understand the concept. So this is a toggle flip flop or T flip flop. T flip flop basically toggles the value, and it's nothing but a JK flip flop, and it is using 1 1 combination as 1 1 combination to toggle the value. Okay, so this is how JK flip flop finally finally successful. Finally got success to use the 1 1 value, and its operation is toggle the value. So if we input 0, it will work as a memory state. If we want input 1 and clock 1, it will work as a toggle. And as you can see, T is joined here for J and K both. And this is final state, and this was the last state. Okay, thanks for watching. এই পার্টটা তোমরা একটু হচ্ছে ভালো করে কেয়ারফুলি দেখবা, because this part is very important for your exam, and as well as I give some references. If you guys want to go in depth about flip flop, you can just read out these books as well as this sites as well. These are very helpful to understand the concept or principles of flip flop. Thank you, everyone. Thank you for watching.